Hello, we're the group consisting of Lee Castillo, Yvette Carreras, Mark Garcia, and today is December 1st, 2014. And today we'll be presenting our database project, Bellman Task and Employee System. So overall, we were approached with the problem of creating an environment that encapsulated the everyday work environment of Bellman performing tasks. The database was designed primarily to optimize the volume of tasks done per day, as well as establishing efficiency with the delegation of tasks to the correct Bellman so the prior objective can be fully realized. So in order to approach a solution to this problem, we created a database with the constraints of business rules to model data and application we use to solve this problem efficiently. Our solution is composed of four components: business rules and ER diagrams, the table schema and normalization, SQL implementation of our schema, and data insertion and manipulation.
These are the business rules we came up with for our project. Came up with each bellman must sign in when their shift starts, and then they sign off when they leave. Only bellmen that are currently at work can be assigned tasks. A bellman must be assigned to a task at all times unless that bellman is on break or there are no available tasks. A task consists of a name, location, status, and comments. A bellman can be assigned multiple tasks at a time. A bellman can be uniquely identified by their identification number. A bellman is considered busy if that bellman is currently working on a task or is on break. And every task must be assigned to at least one employee. For each task assigned to a bellman, the time of assignment must be recorded and the time taken for each task must be calculated. A report with the time worked by each bellman will be needed at the end of each day. The bellman needs to be able to mark a task as complete, and there can be many bellmen in a queue. There is only one bellman queue. So our ER diagrams went through multiple revisions in order to meet the goals of our project, as well as our solution goals for the initial problem. This is our first ER diagram. We found it to be too simplistic, and it didn't meet all the requirements for our project, as well as fulfilling all our initial business rules that we came up with. It was only composed of a queue, bellman, and task. This is our second revision. It was still too simplistic, so we added the assignment entity because we needed more data relevant to the task being assigned to the bellman. And then we came up with this final diagram. This diagram has all the same entities as the previous ones, except we added in a time card that adds in some extra time data, as well as two sub-entities that are subpart of task. This is our table schema that goes off of that ER diagram. You see it was composed of 7 tables. The first one is time card, which holds employee ID and date both as the primary key, and then time in and time out of the day that the employee worked. Employee is our main table. Its primary key is employee ID. It holds the name of the bellman, the status, whether they're busy or unavailable. At work lets us know if they're at work or not at work, and then the queue value. The queue value is held in the bellman queue, which holds their ID. The bellman queue is built based off of a priority system. Then we have task. The task ID is the primary key. There's a type of task. We came up with 3 different types: check-in, check-out, or room change. There's also the location of which the task will be taking place, which would be the room number the bellman is assigned to. There's a task state, which is whether it's finished or unfinished, which also helps us with our sub-entities. And then further comments we wanted to add to the task. Assignment helps us relate the task to the bellman, whichever employee took the task. So that's why the primary key is composed of both the employee ID and task ID. And then we also put an assigned time there so we know when the assignment was actually made. The two sub-entities are finished task and current task. If the task is finished, it has a completion time. If it's current, it shows the status of where, if it's either being worked on or if it still needs to be assigned to another bellman.
Now we'll go over the SQL for the database. First, let's talk about the creation of the database. This script will create the database with all the tables. First, it checks if there's already a database that exists with the name of the database that we're about to create. If there is one, it drops it, as in it deletes it, and that way we can create a brand new one and set it for our use. This set foreign key checks to 0 disables the checking for the foreign keys because we have dependencies between our tables that cannot be fixed by moving the tables. We have to disable this check, then create the table, and then enable it again. So for the employee table, we have a primary key, which is employee ID. We have a string, a varchar with 255 characters for the name of the employee, and we have these other two variables that were described in the ER diagram in the schema design. Then, after we enable the foreign key checks, we're going to create the bellman queue, which has a primary key that has an auto increment property, which means that it's going to automatically increase from 1 all the way to the max capacity of our int. That way we don't have to generate the value for the queue, it's going to be automatically generated. We have the bellman ID, which is a foreign key before we set that it is a reference so that it gets updated every time there's a change. And that was what was causing the problem with the foreign keys. We also have the time card, which the interesting characteristics that we can see are that the primary key is composed of 2 attributes instead of 1. Therefore, we have to declare it this way. And we have a foreign key, which is the employee ID, and we specify where it's being referenced from. We also have the task table, which has 1 primary key, and it stores the type, the location, the task state. The task state, we created an enum, and this is going to be the identifier to use for which sub entity it is. Either this we have it as F or C to simplify the storage space. And then for the comment, we actually added more characters. That way, there's more for the user to input for the comments. We have the table for the assignment, which has a composite primary key. So we have 2 partials, and it has, those 2 are actually foreign keys in 2 different tables, and therefore they're referenced here. There's the finished task. Again, there is a foreign key reference, and there is the current task. See, here we don't have a primary keys because these are sub-entities. So we're going to run this script to create our tables. As you can see, they're all have been created. The next step is to populate our tables for the simulation. And here in this database population script, we have set the loading data for in each different table. And as you see, we had again to disable the check for the foreign keys for this particular table, and then we enable it again so that it's always checking that we don't have any errors. So an example of one of the text files that has the entries for the tables is this one. This is for the time card. It has the employee ID, it has the date, the time in, and the time out. We go back to the creation of the time card, we see that it has the employee ID, the date, the time in, and the time out. So we use the load operation, and we specify the text file location, and we specify which table it goes into. Then we're going to, once we load all this data for the simulation, we're going to display all the different tables. Perfect. So now, so you can see we have the employee table with the data that was input, the time card with the data that was input, the Bellman queue, the tasks, the assignment, finished task, and the current task. That concludes the population of the database.
All right, so now we're going to go over each query and basically how they all combine to help solve our problem. So initially, when an employee logs in, we're going to insert their time card in and essentially just log them into the system. And as you can see, we're inserting that specific employee into the time card, and timeout is currently null because they haven't clocked out yet. Second query, you can see that this query actually logs the user in. So this query basically grabs the current time, which is the now function, and gives that to the time in column on the specific employee and on the specific date. So when we run this query, and let's see if the information gives us. You can see for this user, it currently gives it changes the time into the current time. For the third query, this basically does is when the users or the Bellman is done for the day and wants to clock out, this is the essential clock out function. So instead of time in being changed, the time out column is being changed to the current time and the dates. And as long as the time in is not null, is their constraint. Because usually have to be clocked in order to be clocked out. So let's see what this is. All right. So as you can see, for the date of 12/25, the time in is currently still in place, while the timeout is given the current time. For the next query, this basically sets up the employee status. It tells the system basically that this employee is at work. So it sets the correct columns to 1, which is basically true, and says, okay, this employee is at work. Once that employee, that employee is at work, you could place that employee into the Bellman queue in order to be given tasks for the day. So once that user is actually in the queue, we can allow the ability to insert them into the queue. So let's see if the employee is within the queue and in the employee table. And yep, currently we can see his queue value is 1. And is correctly placed into the queue.
So once the user is logged in, another task we have to take care of is updating the tasks that the bellman handle throughout the day. So here we have our update tasks query that sets the task state to finished. It looks for the current ID of the task, and then we have our flag F that shows that the task has been completed. Once it's complete, we have to insert it into the finished task table. So that way, and then it also updates the current task table. So that way it is no longer in the current task table, and it is only in the finished task table, so that way nobody else can be assigned it any longer. So here it is if we run it. And let's show the task table, the finished tasks, and the current tasks. So this would be the update task query we'd run. So as you see, there is no longer any more task 31. It is now inside the finished task table 31. It shows a completion time. And it is no longer in, or it's still here in the task table, but it is listed as complete with the C. We also have another query that will select all the, it will check to see the assigned time, the completion time, which employee handled that task, and which task it was. And we do this by joining our assignment table and our finished task table. So here we see it updates it, it gives it assigned time now, and then we have the assignment, and we'll show the assignment and the finished task in which bellman completed it. So there we see the new assignments. This is the result of the tables we asked for. It shows all the employee IDs, shows the task ID, when it was assigned, and when they completed it. And that concludes our queries that we would be able to run and perform all our tasks we wanted to complete.
So with this entire database implementation, we hope that this will increase efficiency within the Bellman employee workplace. Thank you for the time to watch this presentation, and if you have any questions, don't hesitate to email us. Thank you and good day.